The objective today is to write a large program from scratch when given directions for each step. So this lesson attempts to walk students through the iterative development process of building an app. You're basically doing this from scratch. That involves the use of if statements. Following an imaginary conversation between two characters, Alexis and Michael, students follow the problem-solving and program design decisions they make for each step of constructing the app. Along the way, they decide when and how to break things down into functions, and of course, discuss the logic necessary to make a simple game. So here's the tough part. The very last step is writing code that executes an end-of-game condition, and you're expected to do this on your own. How you decide to use an if statement to end the game will require some creativity, and the suggested condition for that is the first person to score 10 points should end the game, which is actually subtly tricky and can be written in many different ways. So let's start with the iterative design process. For the test, you must discuss your overall incremental and iterative development process, as well as 2 points along the way where you saw an opportunity or some difficulty that you worked out and it ended up in the final program. So Alexis and Michael's discussion throughout the tutorial is an excellent example of working collaboratively to iteratively write a program. Now they wrote this in small parts, testing each part along the way, modifying it, or adding new functionality altogether. And the realization to use a parameterized function is a good opportunity to create your own abstraction, aka function, aka algorithm. And this is the algorithm that you will be talking about in your Screencast-O-Matic podcast. So the purpose here is for students to see how experts would approach writing an app from scratch when all you have to start out with is a sketch on some paper or an idea. Now, research has shown that what novices often need is an expert walkthrough to explain the rationale behind certain decisions and to see the kinds of problems they anticipate and solve. Some items to consider. There is no one correct way to approach writing a program, and you don't write programs in order from top to bottom. You write them in pieces and organize the code into sections and functions. And the last thing here is you want to start with a small problem to solve and solve it, then move on to the next one. So your think, write, share here is, should programmers write code that works in a perfect sequence or in many pieces that can fit together? The answer to this was, I think, the biggest takeaway in this particular slide. Some more things to think about when programming. You want to use a buddy or a thought partner to talk through things. You want to sketch out pseudocode on paper to get your thoughts straight. And if you get stuck, there's always something small you can do to make progress. Now, I just used the word sequence in a previous slide. Let's make sure you separate that word in your mind. Selection is a generic term for a type of programming statement that is usually an if statement that uses a Boolean condition to determine or select whether or not to run a certain block of statements. Okay, so we're almost ready to start coding. Just know the app you'll make will require you to apply all the skills you've learned so far, and adding event handlers, using variables, breaking problems down into functions, and using if statements are all things we're going to put it together today. So here's your scenario. Michael says, "Hey Alexis, I want to make an app. Can you help me think through it?" Alexis says, of course, happy to. Now Michael's going to say, so I want to make an app that tests people's perception of color difference, but I want to make it a little game. So here's a sketch of what I have in mind. Now each player takes a turn trying to click on the square that's slightly different in color. Some questions we need to answer is, how are we going to do scoring? How does it end? Now some things we want to make sure happen. We want to generate random colors to apply to the squares. We want one square randomly chosen to be slightly different. And then we need to do something to indicate whose turn it is, such as a gray box like this. So I want you to study the sketch Michael came up with and answer these two questions. First, what are your concerns? And second, what would be the first thing you would try to get working on? So here's some possibilities. Making random colors with code. How do you do that? Choosing a random button to make a different color. Knowing whether the user clicked the right button or not. Switching player turns. Keeping track of whose turn it is and the score. And how does the game end? In terms of possibilities for where we can start coding, we can start with the event handlers for the button clicks. We could add a variable or two to keep score. And we can use what we know about random numbers to generate these random colors. So let's see what Alexis and Michael have to say. Alexis says, wow, this is a great sketch. I think I get it. What do you need help with? Michael says, well, how do I start? It seems to me the first thing you probably want to figure out is how to generate the squares of color. Nothing works without that, so tackle that first and worry about scoring and taking turns later. My think right share here, before I reveal to you the JS to generate the color, do you already know? So Michael says, okay, you're probably right. I had an idea for how to do that when I noticed the set property command. Alexis asks, what's that? You know how in design mode you can set up properties of a button, like its color, width, height, and so on? Well, the set property, you can do the same thing with the code. So Michael comes up with this diagram. So under UI controls, you have a set property. Now you'll need to say the name of your element's ID, and you could give this set property a width, but we don't want the width of the button to change or the box to change. We want color. So background color is one of the drop-down options actually. So once you've selected background color, you see here that they're using hexadecimal to indicate a color, but we want those colors to change. So what we can do is use something like this. Set property, button, background color, and then we could put the color in ourselves, or we could break it up like this, where each parameter is a different value for RGB. And if we added another value, like we kept clicking this arrow, so RGB, here's red, green, and blue. If we did another one, that would be opacity, but we don't really need that. So the RGB function actually just returns a color string as well. So if we store the value that RGB returns into a variable, then we can simply plug in that variable as the value for set property for several different UI elements if we want. So below, we'll use my color to set both the button color and the icon color of the screen. So here's the variable, my color. The initial values will be 255, 0, and 0. And down here, set property, we put the variable in. And for the screen, we should not be changing the background color of the screen. So this actually would not apply. Okay, so it's time for you to get your hands dirty. You're going to go to this link and start typing in some of that code. Thank goodness most of the design is already done for you here. So I'll walk you through the bubbles. I just have to delete my code and reinsert it during each step. Okay, so the first thing they want you to do here is set property 3 more times to set the color of the other 3 buttons. So basically, I'm going to highlight that, paste it 3 times, and all I have to do is change the button number each time. So this would be button 2, 3, 4. And then I'll run it to check. Alright, looks good. That's a strange type of orange. And on to the next bubble. Now it says, let's make one square slightly different. Add 2 lines to the bottom of the code you have that looks like this. And there we go. So I'm going to go ahead and cut out the part where I type this up. And if you just need to pause the video, you can go ahead and do that. And be careful here because you can start moving on from the bubbles whether your code is correct or not. This program, when I click finish, it won't actually check. Essentially, I as the teacher just need to look over your shoulder and see if your program's working the way it's supposed to. So here are some parts where it's going to explain the conversation to you. And remember, our goal is bubble 11 by the end of the day here, so right there. So let me do one more with you and then just leave you be. It says we've included the code discussed on the previous page. Now the last lines of your code should look something like this. So check, we got that. But we do not have this variable random. We'll need that. And the comment says it creates a random button ID. And then here's another function, built-in function, that is using the random button variable that we just created up there. So let's just go down here and smush that right in. So there we go. Go ahead and pause right here if you need to study that code. And then it suggests that we add a console.log thing. That way we can see what the random button has been. So us as the programmer, remember that's the purpose of console.log. It's for the programmer. So let's create that here and run and test it real quick. And it looks like it worked. Okay, so keep working on the bubbles. I have the correct code pasted on the wall in the classroom if you really get stuck, and of course I can help you myself. If you're just watching this online, good luck. You can always send me a message and I'll try to help you if you get stuck. So by the time you've hit bubble 11, you've done a lot of creating. And I just want to point out that for a program structured like Color Sleuth, that's the name of this program we're creating, the main algorithm, or the parent, and included algorithms, those are the children, will likely be spread out across separate functions. And an example of a choice that could be made along with arguments for the written response is shown in this diagram. So we're building this huge app right now, and I'm trying to prepare you for the test where you build your own program, and then you have to kind of talk your way through it. So that code narration we've practiced and I've talked about is an important skill that we need here as well. And I just really like this picture because you can see the parent algorithm and how that parent algorithm leads to different children. So with that said, we're at the end of the lesson. Go ahead and pick an IB attribute to compare today's lesson with. If I had to pick, I was going with a thinker, that is, think carefully and show initiative, make good decisions, not only in your program but in class. And this is the big one, solving problems on your own. It's hard for me, but I'm trying to be really hands-off with your programming because of all the creativity opportunities that there are for you inside of the act of programming. All right, and then here's the DOL. Retrace the steps you've taken today, essentially narrating the code you should have written, something like what you see to the right. So you create this function called setBoard. Why don't you just walk me through this, but do it by typing out your answer on Canvas. And right here, because I can't help myself, I'm just going to set this here. It's an exemplary example of code narration. And so if you want to pause here and read it, go ahead. The last thing I want to say is if you just ate this game up today, this Color Sleuth game, and you got all the code done and you're ready for some more challenges, I just put the links up here of other large programs that you're asked to create.